Hello, everyone. Glad to give this talk in SREcon. My topic is shopping event reliability. Before the talk, I would like to give a brief introduction about myself. My name is Jun, a senior engineer of Baidu SRE team. My interesting area is infrastructure of distributed computing, storage, scheduling, and the performance, reliability, capacity. This is my email. If you are interested in this topic, please feel free to contact me. This is the outline. At first, I will introduce the background about shopping event reliability. Then, I will introduce the challenges and share our systematic approach to solve them. At last, I will give a brief of summary that we learned. Okay, maybe some of you guys are not quite familiar with Baidu and Nuomi, so please let me introduce them at first. Baidu is the largest Chinese search engine, which is often called Google of China. Besides search engine, we also have many other products, such as news, cloud, map, and so on. Nuomi is a local live auto service platform for food, movie, hotel, takeaway, ticket, home service, and so on. In Chinese, the word Nuomi means sticky rice, which is a famous food in China. There are millions of orders per day and hundreds of millions of GMV per day at Nuomi platform. In China, shopping event is the most important marketing strategy of O2O, which is one of the 5 development segments in the Chinese market. There are shopping events almost every month in China, every month. And the 2 biggest may be Singles Day, which is China's Black Friday and Chinese New Year. This chart describes the shopping events at Nuomi last year. It's just like a war for SRE team, nearly every month. It's very challenging that SRE team keeps the website and mobile apps high reliability. The first challenge is that the traffic flow is much more than usual. And the second is that many different engineers and change events are involved in this event. Latency and data consistency are also important for tens of millions of online customers in the shopping day. The left chart describes the difference of QPS between the shopping day and the day before. The right chart describes the departments involved in the event, including software development, marketing, instructor, sys, and SRE team. Okay, well, this is our solution for shopping event reliability. There are 5 important parts. The first is traffic control. Although we can estimate the flow during the shopping event according to the shopping event, according to the prediction from the history data or marketing strategy. But you know, it's also risky because it's hard to estimate with no errors. The second is capacity management. We need to prepare adequate resources in advance and ready to auto-scanning at any time using the idle resources. The third part is monitoring, just like a camera, which needs to capture all the events occurred during the shopping event. The fourth is the multi-homed systems, which keeps at least N+1 redundancy. Process management is the last one, which can be divided into 3 strategies. before, during, and after. Well, next, I will describe some details of our practice about these 5 parts. The first part, traffic control. The purpose of traffic control is to avoid the avalanche. Even there is a capacity planning, but there is also a risk because marketing is hard to be predicted. The service needs to have the function of overload protection. The left chart is a simple architecture description. Here, overload protection is through from the front to the end of the service, including native app-side throttling, global protection, service protection, database protection, and other platform-related. The main trigger index of the overload protection includes utilization of resources, active state of CPU, quotas of QPS, and receive buffer. Graceful degradation is very important when overload protection is occurred. There are 3 methods we use. Flexible reliability, which means grading and decouplling the features of the product. Independent second tier service is an example of the method. Static environment is another method, which means using an old service and a data mirror image service. Well, the environment needs to be simple, independent, automatic, and keep high hit rate. Comfortable notice is used in service field widely, and it also needs to be simple, independent, and automated. The second part, capacity management. This is the most important part for shopping event reliability. We use a method called scenarios-based capacity planning. These scenarios include marketing scenarios such as sending coupons, pushing messages, and user behavior scenarios such as landing, shaking, sharing, searching, ordering, and payment. We choose 2 types of indicators for capacity planning. One is business objectives, including active users, QPS, GMV, the number of coupons. The other one is service level objectives, including latency and reliability. Based on the 2 types of indicators, we find the better cost-effective solution through load testing. The load testing tools, including simulation tool, playback tool, and data collection tool. We use calculation analysis method to find the minimal water level of the service and predict how many resources we should need during the shopping event. Okay. We use this 3-tier structure to implement the strategy plan as well as real-time adjust. At the bottom, the service is containerization by a global resources manager system named Matrix, just like Apache Mesos or Google's Borg. In the middle tier, there is an online running platform named ORP for SI team. At the top, there is an auto-scanning service which interacts with ORP system. Okay, this page is the user interface of our elastic container system. The third part is monitoring. During the shopping event, we also spend a lot of effort to monitor all the events, including infrastructure failures events, configuration events, deploy events, dependent platform events, and key indicators of normal events. Based on the events collected, we process and analyze real time, and we will get an event flow graph. This event flow graph is very valuable for us to find the root cause of the problem in a few minutes. The third part is the multi-homed systems, which keeps at least n+1 redundancy. Earlier, we have a master back service cluster, which can be both read and load by customers. And we have several other slaver clusters, which can only be read and seek data from the master. The disadvantage of this approach is that the risk of the master cluster and the latency caused by multiply interactions across the clusters. And in our application, it is suitable for less than 10 milliseconds between clusters. However, when the latency is over 30 milliseconds between clusters, it's not suitable for some function of the service. Later, we redesign the system using the method of unitization. Every unit service for specific customers. There is no master-slave relationship between clusters. Data is synced between those clusters. Okay. The last one is process management, which can be divided into 3 stages. Before the event, there are 5 processes should be done, including marketing forecast, capacity planning, failure drill, deploying restrict, just like error budget, auto scanning out. During the event, on-call in one operation center is useful for reducing communications cost. After the event, we also have the process of auto scanning in, data review, and post-mortem. Well, at the end of my speech, I will give a summary about what we have learned. For traffic control, both over protection and graceful degradation are important because there are a lot of unpredictability in shop event. For capacity management, scenario-based, considering business objectives and SLOs, collecting data of hardware, for example, utilization, and software service level objectives, using historical request data. For monitoring all events in shopping event, building an event flow graph. For multi-homed systems, utilization is very important in our product. For process management, the important thing is standardization and on-call in one operation center. That's all. Thank you. Any questions? The overview of my talk is here. Okay.
In one of the slides, you talked about doing the postmortem.
Oh.
Do you do the postmortem only if you encounter any issues, or regardless of whatever happens, just go to the
是吗？有吗？我动个一下。Please let me my colleague here.
Okay.
Please.
So in one of the slides towards the end, you talked about doing a postmortem. So the question is, do you do the postmortem only if you encounter any issues, or is it regardless of what happens and just to go through everything that happened and go through that?
So answer is the postmortem is basically for some main, very serious event, not for the all event.
Okay.
Serious event. It's
Okay,
only
so-
for serious event.
Okay. Okay.
我听懂后面。OK。
You mentioned for the multi-home systems that it's separate clusters and they each have their own master database, and then you quickly mentioned that they do some synchronization. What did you mean by that?
We design a high-performance database, maybe just like F1 or a Spanner, but smaller than it, to synchronize the data.
Okay, thank you.
Okay, thank you. That's all.